It's a pleasure meeting all in another video on Upthrust. So let us discuss a few MCQs. 1990 MCQ 57. Here we are to compare the liquid levels when a block of density that is greater than water is placed within a beaker and out of the beaker. Now let us see how we can get the relationship in between them. We know that upthrust is equal to the weight of the displaced fluid, that is U is equal to V rho G. As the liquids are same here, the densities are same, thus upthrust is proportional to the displaced volume. Here, upthrust in case 1 is greater than the upthrust in case 2, therefore the volume displaced in V1 is greater than V2, thus height H1 is greater than height H2. But wait, how U1 is greater than U2? Let us explore. Here we have two cases. One, the object is floating, and the other case, the same object has been sunk. Now, for the ease of explanation, let's consider the weight of the beaker as weightless. Marking the forces, we have upthrust acting in case 1 and mg downwards. In case 2, we have upthrust, the reaction given by the beaker, and mg. Considering equilibrium, we are able to obtain that U1 is equal to mg, and in the second case, U2 is equal to mg minus r. We are using the same object, therefore the masses are same. Comparing these two, you must be able to understand that U1 is greater than U2. Here we can observe that U1 is greater than U2 clearly with the above idea. Therefore, the height H1 is greater than H2 is now clear. With that, we are able to approach this question. It's obvious that H2 is greater than H1. When we compare H2 and H3, according to this idea, H3 has to be lesser than H2. Therefore, this second answer is correct. Next, we have 2005 MCQ question number 59. Statement A says that when a stone is taken out of and dropped in water, height h decreases. But according to our previous explanation, you must be able to understand without any objection that statement A is correct. So with a few more explanation, let us understand about statement B and C. Let us consider two systems of beakers as I have shown in the diagram. In a case where the wood is within the beaker and in another case where the wood is out of the beaker. Our objective is to find the liquid levels H1 and H2. In instant 1, we have two forces, weight of the beaker and weight of the wood acting downwards, and where it is balanced by the upthrust alone. Considering equilibrium, we are able to obtain the above equation. In case 2, again we have the weight of the block and the weight of the beaker downwards, and this time we have two separate upthrust acting on a block and acting on the beaker. By a close observation, you must be able to understand that the right hand sides of the both equations are equal. Thus, the upthrust in case 1 and upthrust in case 2 are the same U1. Upthrust are the same, thereby the displaced volume is the same. Therefore, the heights H1 and H2 has to be equal. So, the second statement is also correct. Statement C inquires about the water level when both the wood and stone are tied together and sunk to the bottom. Now, in system 1, I'll have the wood and stone within the beaker. And let us mark the water level in red. When we take out the stone from the beaker, we know there is a drastic drop in the water level because so far the upthrust was balancing the weight of the stone. Now when I drop it into the water level rises a little. That's because the water displaced that is equal to the volume of the stone. And in the third case, I have taken the piece of wood and dropped it into the liquid. There is no change in water level as we have discussed before. And finally, when the stone and the wood are tied together and sunk to the bottom, a displacement of water is observable, and that displacement is equal to the volume of the wood that was above the water level when it was floating. Even though there is an increase in height, it is not higher than it was initially. Statement C says there is an increase in height, therefore the answer has to be A and B, second answer. Hope to meet you all with another video. Thank you.